Alrighty, chapter 21, number 77. When a mass m is tied to the bottom of a long, thin wire suspended from the ceiling, the wire's second harmonic frequency is 200 hertz. Adding an additional 1 kilogram to the hanging mass increases the second harmonic frequency to 245 hertz. What is the mass m? Alright, so we're looking at the second harmonic frequency, and we're told that the second harmonic frequency without the mass is 200 hertz. So this value is known, okay? And we know that that is equal to the velocity divided by the wavelength, okay? Which is equal to 1 over the wavelength times the velocity of a wave on a string, which is the tension in the string, divided by the linear density mu. Okay, and similarly we can write down this F2, which is the second harmonic prime, which is when we're hanging the other mass over that, which is going to be equal to V prime over lambda. Once again, the rope or the string does not stretch enough to change the value of lambda here. So this is going to be 1 over lambda times the square root of the tension Ts prime divided by mu. And we don't change any properties of the string, so that is also not going to change. Now in the initial situation, we have that the tension in the string is just going to be our original mass times g, assuming that the string is not accelerating. The tension just opposes the force of gravity, and that force of gravity is mg. And the new tension is going to be equal to m plus delta m times g, where delta m is our 1 kilogram weight that we add to create the new oscillation. Okay, so we can plug both of these expressions in, Ts and Ts prime, into these expressions we did earlier. We're going to get 1 over lambda times the square root of mg over mu, and down here we get 1 over lambda times the square root of m plus delta m times g over mu. And we're going to call this equation 1, and we're going to call this equation 2. Now, we know F2 and F2 prime, those are given, 200 hertz and 245 hertz. We know m. We don't know delta m. We don't know mu. We don't know lambda, right? Many of these things we don't know. So in order to cancel everything that's the same, what I want to do is take equation 1 and divide it by equation 2. Okay, so on the left-hand side, we're going to get F2 divided by F2 prime is equal to, the lambdas are going to cancel, the g's are going to cancel, the mu's are going to cancel, and so we're left with, on the right-hand side, just the masses, m on the top, and the square root of m on the top, and the square root of m plus delta m on the bottom. Let's go ahead and square both sides of this equation. We're going to get F2 squared divided by F2 prime squared is equal to m divided by m plus delta m. Let's multiply both sides by m plus delta m. So on the left-hand side, we're going to get m plus delta m times F2 squared divided by F2 prime squared is equal to m. And what we want in this expression, or in this problem, is the mass m. So we want to get that side guy by itself, but we have this one over here as well. So if we multiply through and subtract, we're going to get delta m times F2 squared over F2 prime squared is equal to m times 1 minus F2 squared divided by F prime squared. All right, so we're still trying to get m by itself here, and I think what I'm going to do next is divide both sides by this expression here. So it's going to cancel, and we're going to get one of those over there. So on the left-hand side, we're going to get delta m. On the right-hand side, we get m times 1 minus F2 squared over F prime squared. Okay, and then we have times F2 prime squared over F2 squared. So these guys are going to make a 1, and this guy is going to end up over here on the left. So we get that delta M is equal to M times F2 prime squared divided by F2 squared minus 1. Getting close here, we get that M is equal to delta M divided by F2 prime squared over F2 squared minus 1, which is equal to 1 kilogram divided by F2 prime was 245 hertz. Divided by F2 squared, which was 200 hertz, minus 1. Putting that into our calculator, we get that M is equal to 2.0 kilograms.